Hi, I'm Victor, and I am a student. After lectures, I often used to work at home. Recently, I started to notice that I'm getting tired much faster than expected. A small research about factors influencing productivity pointed towards air quality and the effect of high concentrations of CO2. I always knew that it is important to ventilate the room occasionally by opening the window and allowing the fresh air to come in. However, during the winter time, this dramatically lowers the room temperature, requiring additional time and resources for heating. This made me think of a device that will allow people like me to know exactly when fresh air is required. I started sketching design ideas and then discussed them with my friends and neighbors. They provided valuable feedback and helped me define the necessary set of features in terms of look, feel, and weight of interaction so that it could fit a broader set of users. I moved on by experimenting with different prototyping techniques. For the initial grasp of size and form, I used simple paper. Considering all the measurements, I then built the shape in a 3D modeling software. For translating the digital model into a physical one, I tried laser cutting the acrylic plastic, which came with a set of big challenges. To simplify the process, I tried an automated program that meant to do everything auto-magically, but it didn't work for me. A much longer but more precise alternative way that provided exactly what I expected was 3D printing. The only compromise was time, 15 minutes versus more than 12 hours. For bringing the prototype alive, some electronic components were required. I tried various platforms as Raspberry Pi, Pi Zero, Arduino Uno and Arduino Nano, and finally agreed upon Arduino Nano due to its smaller size and easy to start with platform. For measuring the CO2, there were two options, one based on chemical reaction and another on infrared technology. Although bigger in size, I chose the latter for its reliability. After making sure that everything works as expected on a breadboard, I soldered a custom board. The physical prototype that I designed consists of several components: an accurate CO2 sensor, NeoPixel stripe, a Wi-Fi module, and Arduino Nano that acts as a controller. The sensor measures the amount of CO2, which is mapped to a scale from a minimal to maximal recommended concentration, and color-coded in the range from blue to red respectively. Depending on the amount of CO2, the NeoPixels will be smoothly colored. This shows the current state. All these have been nicely fitted in the previously printed case. For having an overview over the last 24 hours, the user can tap an NFC-enabled phone to one of the edges and a monitoring web page will load automatically. This can be helpful for determining the noxious factors as well as some patterns. Now, being aware about air quality and knowing when to ventilate the room, it is easier to maintain a healthy lifestyle and keep high productivity levels.